Hello, my dear students. I welcome you all to the part number 4 of chapter number 4. Student, in this particular part, we will discuss regarding the isotopes and isobars, and we will also deal regarding these few important subtopics, that is atomic number, mass number, isotope and its uses, average atomic mass, and isobars. Students, after watching the video, you all will be able to define the atomic number. Then you also will be able to solve the numerical problem based upon the atomic mass. Then you also will be able to define isotopes, and you also will be able to recall the uses of isotopes. Then after this we will also learn how to calculate the average atomic mass of isotopes, and in the end, last but not the least, you also will be able to define the isobars. This particular section that we are dealing here, student, you can read it from your NCERT book from page number 51 to page number 54. So let's start our class. Today we will discuss regarding the very first important key term, that is the atomic number. So let us understand it. Students, these are the first 20 elements of the modern periodic table, that is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So you might be able to see here that hydrogen is placed at the first position, helium is placed at the second position. So what these numbers are actually? These numbers are actually none other than your atomic number. And what is the meaning of atomic number? Students, atomic number simply means the number of protons that are lying in the nucleus of a particular atom. Likewise, here you can see the definition of the atomic number. The total number of protons lying in the nucleus of any atom is called as its atomic number. And students, this atomic number is usually denoted by the symbol Z. Here Z simply means number of proton inside the nucleus of any atom. Suppose if you have drawn the structure of these elements, then you might be aware in the center we are having the nucleus, and inside the nucleus we are having two subatomic particles, that is neutron as well as the proton. So this atomic number is simply the indication that a particular element is having how many number of protons, and that is usually represented by the symbol Z. And students, for a particular neutral atom, this Z, that is atomic number, is always equal to the number of proton. And in the last class we also have studied that number of proton is also equal to the number of electron. So from here we can conclude that atomic number for any element is equal to its number of protons, and for a neutral atom it is also equal to the number of electron, that is Z is equal to P is equal to E. So this is the atomic number. So this is the concept of atomic number. So let's move ahead. So students, here in this particular table we will try to apply the concept that we have learned in the previous slide. And in the previous slide we have learned that atomic number is always equal to number of protons, and that is also equal to number of electrons, that is Z is equal to P and this is equal to E. So in this particular table, students, you are able to see a lot of blanks are there, a lot of blanks. So this is given in order to check whether you have understood the concept of the atomic number or not. Then let us understand it by doing one or two examples. Let us take the very first example of the hydrogen. Suppose if the hydrogen atomic number is 1, then how many number of protons it must have? It must have 1 proton, because we have learned that Z is equal to P and that is equal to E. Atomic number is equal to number of protons, and number of protons is also equal to number of electrons. So that's why number of electrons in hydrogen is also 1. Okay, so in this particular fashion or in this particular manner you have to do, or you have to complete all these blanks, you have to fill all these blanks that are there. So let us take another random example from the next section, that is from here. Likewise, suppose for chlorine the atomic number is 17. Then how many proton it must have? The number of proton inside the chlorine must be 17. And how many electrons it must have? It must have 17 electrons. Remember that this particular concept, that is Z is equal to P is equal to E, is applicable only for the neutral atom. So this is how you have to complete all this table. Hope so you are able to do it. Then let us move ahead and let us discuss regarding the second concept, that is your mass number. Student, mass number is simply the number of protons and number of neutrons inside the nucleus of an atom. As we have discussed in our part number 1, that is, inside the nucleus of a particular atom there are two subatomic particles, that is neutron and protons. Suppose this is the nucleus of a particular atom, and outside the nucleus we are having defined shells according to the Bohr and Bury concept, likewise K shell, L shell, and so on. And inside the nucleus we are having two subatomic particles, that is neutron and protons, and mass number is simply the number of protons and number of neutrons inside the nucleus. And let us understand it with the help of a formula. Atomic mass or mass number is simply represented or denoted by letter capital A, and this capital A is equal to number of protons, that is Np, plus number of neutrons, that is Nn, small n and capital N. And if we will try to combine all this concept, then we can make the definition of mass number. What is mass number? Mass number is simply the sum of total number of protons and neutrons that is lying in the nucleus of an atom. In short, we can simply say that A, that is mass number, is equal to number of neutrons plus number of protons. This formula you can also use, that is A is equal to N plus P. So let us understand the concept of mass number with the help of few examples that is given over here. So let us attempt few questions from here. Suppose here in this question what the examiner is asking, calculate the number of protons, electrons and neutrons for A part is given, that is for this chlorine 1735 you have to calculate the number of protons, number of electrons and number of neutrons. Student, we know very well this 17 is the atomic number of chlorine, because any particular element is represented in this particular manner. We will also discuss regarding this concept in our next few slides, that this is the symbol of the element and this is actually the atomic number and this is your mass number, and here this atomic number Z is equal to 17, and from the concept we know very well that Z is equal to P is equal to E. Simply means that for this particular part number of protons is also 17, number of electrons is also 17, but how many number of neutrons this chlorine is having, that we will calculate with the help of the concept that we have learned. What is the formula for calculating the atomic mass? Atomic mass can be calculated by number of protons plus number of neutrons, and atomic mass of this chlorine is 35. So put the value 35 here, and then number of protons are here. How many number of proton it is having? 17. Then can you find the number of neutrons? Yes, it is quite easy. Keep it here. That is number of neutrons equal to 35 minus 17, and 35 minus 17 becomes 18. It simply means that number of neutrons inside this chlorine is 18. So this is the number of neutrons for chlorine atom. So this is how you have to solve the another part also, that is for sodium 1123 you have to calculate the number of protons, number of neutrons and number of electrons also. So let's move ahead to the next concept. Yes. So here we will discuss regarding the representation of a particular element. In the previous slide, students, we have also discussed regarding this concept, that how to represent a particular element. So this is the way that you have to represent the particular element, and in the center this X is actually representing you the element symbol. Here you have to put the symbol of a particular element, and at the top, that is in the superscript, you have to write the A, that is the mass number, and this mass number we know very well, it is equal to the sum of number of protons and number of neutrons that we have learned in the previous slide also. And in the subscript, that is at the bottom of this particular element symbol, we have to represent the Z, that is the atomic number, and this atomic number is simply equal to the number of protons. So this is the way that you have to represent a particular element, and this is the rule that you are going to follow for each and every element. So let us understand it with the help of few examples given over here. Likewise, these are the examples given over here, that if we have to represent the carbon element, so this is how, this is the symbol of the element, this is the symbol of the element. And what is this 6? This 6 is actually indicating you the atomic number. Atomic number simply means Z at the subscript at the bottom, and at the top this is actually the mass number. Mass number is simply indicated by the A. So this is how you have to represent the element carbon. Let us understand it with the help of the another example. Likewise, this is helium. Again, helium symbol in the center, and then atomic number at the subscript. The atomic number of helium is 2, and the mass number at the superscript, that is mass number for helium, is 4. Likewise, for hydrogen, atomic number is 1, and its mass number is also 1. So this is how you have to represent the element. Likewise, for oxygen, it is 8, atomic number is 8, and atomic mass is 16. So this is the way, this is the concept that you have to learn, that how to represent a particular element. You always have to follow this particular rule, that at the bottom, at the subscript, you have to place the atomic number, and at the superscript you have to place the mass number of that particular element. So let's move ahead. Here in this particular slide, student, we are discussing our third important subtopic, that is the isotopes. What are isotopes? Let us understand that isotopes are simply the atoms of same elements having same atomic number and different mass number. Let us understand it with the help of the examples given over here. The very first example that is given over here is this, that is protium, deuterium, and the tritium. Student, these are the three isotopes of the hydrogen element, and if you are able to see here, this protium is H11, and this deuterium is here H12, and this tritium is actually here H13. And from the previous slide, if you are able to recall, this subscript is what? It is atomic number or mass number? It is actually here atomic number. And this superscript, that is 1, 2, and 3 at the top, this is actually your mass number. So according to the definition, it is quite clear that here in this particular atoms, in these particular atoms, the atomic number is same. Atomic number is same, but the mass number is not same, or mass number is different. So students, isotopes are quite easy to understand, that isotopes are simply the atoms of the same element. Likewise here, this is hydrogen, this is hydrogen, this is also hydrogen. These are the atoms of the same elements which are having the same atomic number but different mass number. So this is how you can learn the definition of the isotopes. And the another examples of isotopes are given over here. Likewise, this is carbon C612, this is carbon C613, this is carbon C614. Here you can see atomic number is similar in each case, because these are the atoms of the same element. Their atomic number Z is same, but here their atomic mass, that is A, is different. Here 12, here 13, here 14. So this we have learned from here, that isotopes are generally the atoms of the same element which is having the same atomic number but different mass number. Another example is given over here, likewise the chlorine 1735 and 1737. Their atomic number is same but their mass number is different. So this is about the isotopes. Students, these isotopes are of very important use, and there are three main important uses of these isotopes are given over here. That isotopes of uranium, they are used as a fuel in the nuclear reactor. Then second use of isotopes, that isotopes of cobalt is used for the treatment of cancer. And third use of isotopes, that is the isotopes of iodine is used in the treatment of goiter. So these are the three uses that is also given in your NCERT book. Clear? So this question can be asked in this particular manner, that what are isotopes? Give one or two examples and write any three uses of isotopes in 5 marks. So prepare accordingly, that what are isotopes, learn their examples, and what are the uses of isotopes. So let's move ahead. Here student, if you are able to understand the concept of the isotopes, then here we have to understood that how to calculate the relative atomic mass. What actually is the meaning of relative atomic mass? First of all, let us understand it. That relative atomic mass is an average of masses of all the isotopes of the element. Suppose, let us understand it with the help of an example. Likewise, there are two isotopes of chlorine, as we have understood in the previous slide also. These are the two isotopes of the chlorine, that is 1735 and 1737, and in nature generally they are found in the ratio of 3 is to 1. If we have to understood that how to calculate the relative atomic mass, then simply pay attention here. Let us understand here that if these two isotopes are present in the ratio of 3 is to 1, they are present in the ratio of 3 is to 1. So what fraction of this isotope is present in the mixture? Can you tell me what fraction of this chlorine 1735 is there and what fraction of chlorine 1737 is there in the mixture with the help of this ratio? Can you tell me? Student, if the ratio of these isotopes are 3 is to 1, then here 3 and 1 total 4, and the fraction of this particular isotope is 3 by 4, and here the fraction of this isotope is 1 by 4. What is the meaning of 3 by 4? 3 by 4, if we will find out the percentage for this particular isotope, then 3 by 4 multiply 100, and for this 1 by 4 multiply by 100. So this becomes 25 into 3, that is 75%, and here it is 425. It is actually 25%. So these isotopes, that is chlorine 1735 and chlorine 1737, are actually present in the ratio of 75% is to 25%. Then let us understand how to calculate the relative atomic mass or the average atomic mass. How to calculate the average atomic mass? Let us try to calculate the average atomic mass for these two isotopes. Students, the formula for calculating the average atomic mass is very simple. Here we have to write the mass number 1 of the first element, likewise 35. We have to multiply it with the percentage of the first isotope. How much percentage is there? Then mass of the second isotope, that is this 37, and its percentage and its relative percentage here. Then average atomic mass can be calculated. That mass of this first isotope is how much? 35. Multiply, what is the percentage, what is the fraction of it? That is 75%. Percent means 1 by 100. Percent means 1 by 100. Plus mass of another isotope is 37. And what is the fraction, what is the percentage of it? 25%. 25% means 1 by 100. Then solve it. It is quite simple. 25 3 is 75, 25 4 is 25 1 is 25 4 is, and becomes how much? 35 into 3, that is equal to 33 is 90 and 5 3 is 15. 105 divided by 4 plus this is 37 by 4. Then 4 will be the LCM, and 105 plus 37. So this becomes how much? 142 divided by 4. So solve it. 4 3 is 12, 2 left, 4 5 is 20, 2 left, 0 carry, 0.45 is 20. So that's why the average atomic mass of the chlorine is 35.5. In chapter number 3 you also have used this mass, average atomic mass there, that is 35.5. If you are able to recall, when you have calculated the empirical formula mass for NaCl, Then Na mass is 23 plus chlorine mass we have taken there 35.5. So this concept there, actually it is not like that. In the chlorine half neutron is there, but chlorine in general is actually present in the 3:1 ratio, and we people are taking their average atomic mass. That's why the average atomic mass of chlorine is taken as 35.5. It is not like that they are having the half neutron. There is no concept of half neutron is such kind of concept. So this is how we are calculating it. Student, let us move to the last concept of the video, or last concept of the chapter, that is related to the isobars. As you know very well, we have studied about the isotopes. If you are able to recall the concept of isotope, that isotopes are the atoms of the same element where atomic number is same and the mass number is different. So students, here we have to discuss regarding the concept of the isobars, and if you are able to see the examples here, that is the example here, with the help of this example we will try to make the definition of isobars. Let us understand the example first of all. This is actually argon, this is your potassium, and this is your calcium, and see their atomic number. See, their atomic number is 18, potassium atomic number is 19, and calcium atomic number is 20. So here we can say that Z1 atomic number of argon, potassium and calcium, Z1 is not equal to Z2 and Z2 is not equal to Z3. Means atomic number of these different atoms of the different elements are not same, but we will see their mass number. Their mass number are equal. They are actually atomic mass of argon, potassium and atomic mass of the calcium are same. So that's why, what are isobars? Isobars are the atoms of those elements which have the same mass number. Here the atomic mass is same, but the different atomic number is there, and these are actually known as isobars. And this is the example of the isobar. So this is about the part number 4. That is the last part of the chapter number 4. So with this we have finished our chapter number 4. You are supposed to complete the NCERT exercise and blue box question, and after that you are supposed to attempt these practice questions. These practice questions are related to the section, that is part number 4, that we have discussed over here. And after doing this you are supposed to prepare the notes, and then in the end I will say simply thank you to everyone. Thank you for watching the video. If you like the video, hit the like button, share the video and subscribe the channel too. Thank you. Bye bye. We'll meet in the video of the next chapter. Thank you. Bye bye.